Okay, hi everyone. I hope you're doing well. So I'm gonna in this video I'm gonna explain and I'm gonna visit again chapter 8. Chapter 8 is a continuation for chapter 7. Chapter 8 is divided into two main parts. The first part is about the nebula, the cloud of gas that has formed our solar system, and this is what we call the solar nebula. The second part of this chapter, the most important part actually in this chapter, is exoplanets. And to be more specific, it will be about how we find exoplanets. What are the methods astronomers use to find planets orbiting stars other than our sun? There are 5 methods that we're gonna discuss. But before we go through those 5 methods, let me first get on with the first part of this chapter, which again talks about the solar nebula that formed our solar system. So this is an image from chapter 7. You have the 4 inner planets, the 4 outer planets, the asteroid belt, the Kuiper belt, and the sun. Okay, so what has formed all of this is nothing but a cloud. Think of the Orion Nebula. The Orion Nebula, you can Google it, Zanacina. You see a very large cloud of gases, mainly hydrogen and helium, being compressed and forming new stars. This is exactly what happened in our solar system. But in our solar system, we don't call it the Orion Nebula, and Orion Nebula is forming stars other than our sun. We name the cloud that has formed the system, our system, the Solar Nebula. Again, Holiman, chapter 7. So I don't want to confuse you, but this slide here, Heidi Lihon, and this one here, they are only trying to tell us the abundance of elements found in the universe and the abundance of elements found in our solar system. And we have talked so many times about the two most abundant elements in the universe, and the hydrogen and helium. Hydrogen and helium, they fill up our universe, they fill up the solar system, and they fill up all of the stars and their exoplanets. This is the distribution of chemical elements in our universe. And since our solar system is part of the universe, when we study the percentages of chemical compositions in our solar system, this is what we get. إنه around 98%, يعني this one combined with this one, around 98% of the solar system is made from hydrogen and helium. And only 2% of the solar system is made from other elements. شو يعني other elements? يعني anything other than hydrogen and helium. Example, oxygen, carbon, nitrogen, iron, diamond, and all of the other elements you hear about, and they only make 2% of the entire solar system. And this same phenomena is also seen, or this same fact actually is also seen in the universe. The universe is also made from around 98 to 99% hydrogen and helium, and only 1 or 2 or 3% is made from other elements. Yani, what I'm trying to tell you is that the abundance of elements in the universe is not very different from the abundance of elements in our solar system. And our solar system was made from a cloud that was made in the universe, if you know what I mean. So yeah, this is the case with our sun, with all of the stars you see in the universe. Most of the elements are hydrogen and helium, and very small percentage of the elements in the universe in غير hydrogen and helium. Now I don't want to go in the reasons for why this happens really, but we're gonna talk more again about this in the chapter of stars. بس تذكروا إن hydrogen and helium were created after the Big Bang, and the other elements can only be created inside the stars. So hydrogen and helium had so much time to be created, not inside the stars but outside the stars. So it is easier to make hydrogen and helium. Don't worry about this so much now. هذا الشيء اسمه chemical abundance in the universe, and this is something we will discuss later on when we talk about the evolution of stars. بس عرفوا the distribution of the elements in the universe as well as in the solar system. Okay, كمان هون I've briefly explained about this. You don't have to focus a lot about this slide now. Just know that this is hydrogen, this is helium, وكل شيء تحتهم هن بالperiodic table هن the other elements that make up 1 or 2% of the solar system. When it comes to this slide, كمان I don't want you to focus on it. هنرجع نحكي فيها later on. But this thing, or this topic, I've already discussed many times since the beginning of the semester. It only tells you about how stars die, and stars as big as our sun would die with a gentle way. Yani they would expand, they will pulsate, they will throw their gases. And stars that are really, really massive and larger than our sun, they won't just pulsate and throw their gases. They will actually explode with a supernova. Again, انسوا هيدا information for now. نحكي فيهم later on بعدين. Okay, and just as a side note, I just want to tell you that the space between stars, yani if I want to go to Proxima Centauri, which is the closest star to Earth, the space between our sun, our solar system, and that star is what we call the interstellar medium. Stellar يعني stars. The interstellar medium يعني the space or the distances between the stars. أعطيكم another example. The distances between planets in our solar system ما اسمه interstellar medium, اسمه interplanetary medium. يعني it is the space or the medium between the planets. This is only a name that we give for the spaces between the stars, and you are responsible for it. And just know that 90% of your body masses is actually made from elements that were formed in stars actually. Yeah, because كل شيء إلا hydrogen and helium are created in stars. So when you look at the human body and you see that it is made from carbon, nitrogen, iron, كل هول الأشياء, you realize then these elements were made in stars and somehow they made it to our bodies, to our human bodies. So if you want to do statistics, you will realize that 90% of the atoms found in a human body was made in stars back in the time. This is all you need to know. So this is an old picture of you when you were a star. Yeah. So this is where I show you how the solar nebula, this is the cloud that formed our solar system. It was compressed due to the gravity. When it is compressed, you get a new what we call a protostar. يعني هون بلش الهيدروجين يتحول لهيليوم. And then some of these gases here couldn't make it to the central part, the protostar, so they will form a disk around the star itself, the protostar. Now this disk later on will get cooler, dust particles will accumulate on each other to form larger bodies like here, and then eventually this will be turned into that. What you are looking at here is numerous numbers of asteroids all orbiting around the protostar before the creation of our planets in the solar system. This is the process of how the solar system was created anyway. يعني هيك كان السولار system قبل. But with time, give it a few million years, this is what happened. هيدا الانر solar system كان في the sun, the many asteroids orbiting around the sun. The asteroids صاروا يلزقوا ببعض to make larger asteroids, and then these larger asteroids were accumulated on each other to form the 4 inner planets. This is really briefly how our solar system was formed from a solar nebula. ما لازم يكون شيء جديد عليكم, because we've talked a lot about how stars and planets are formed many times before, and our solar system is no exception. مثل ما بخلق السولار system كل الستارز بالuniverse بيخلقوا بنفس الطريقة. Remember, the laws of physics are universal, they don't change, it's the same here and in other galaxies. So yeah. هذا الشيء اللي حكيناه. So guys, this was the first part of chapter 8. briefly مرقت عليه وحكيتكم عن اشياء that you should already know anyway. Now this is the newer part in the chapter. This is the part where I'm gonna explain about exoplanets. How do astronomers find exoplanets? And before doing this, these are artistic images. So for some of the exoplanets found that we have found in the universe, like Kuhaida مثلا, it looks like Jupiter. It's not Jupiter. Well, this is Saturn. This looks like Jupiter, مثل Jupiter. So these are the gaseous large planets. These are smaller planets هون. Some planets have rings. So they come in different sizes, different shapes. Look at that big beer, and so on. But please انتبهوا إنه these are only artistic images. We were never ever able to take a direct image for any of those planets, unfortunately. So yeah, if I want to show you the map of the exoplanets that we have found, بيكون in this video. But before I do this, one might wonder, إنه we know as a fact that planets exist around stars, around all stars. And when we look at the number of stars in the Milky Way, we find that we have around 100 billion stars in the Milky Way. Type around every star we will have planets. And if you want to count how many galaxies there are in the universe, بيطلع عنا trillions of stars. حوالين كل star في planets. So في trillions and trillions of planets in the universe. طب ليش مش كل يوم بنلاقي planet? The problem is, although we know that these planets exist around the stars that we see, our problem is with detecting them. Our problem is with having very large telescope to zoom in as much as we need to take good images for those planets. We know that there are so many planets. Our problem again is with our technology. Our problem is with the distances between us and those stars. هعطيكم example. فكروا ببلوتو. حتى from Earth, Pluto مش بالسهل واحد فيه يشوفه. And Pluto is still in our solar system. ما بده maybe a year for us to reach Pluto. طيب, how about looking at a planet which is hundreds and thousands of light years away from us with a telescope? إذا Pluto صعب علينا, those other planets will be really difficult for us to look at. But in any way, this here, this will show you the planets we have found. This is showing you the map of the planets we have found orbiting other stars. Had a solar system. These are two planets orbiting a nearby star, or two planets orbiting other star, two planets orbiting a star home. And you see the distribution of the exoplanets. We see only 3 planets مثلا orbiting their star. There might be more planets around those stars, but this is how much we can see. It's really cool to look at those videos showing you good maps. إذا بتلاحظوا إنه طيب in this region وينهم exoplanets, in this region وينهم exoplanets, similarly here. Problem is, it's very hard to look at exoplanets here. We know they exist everywhere, but this is what we were able to confirm. Scientifically confirm them. تقريبا في 4,000 confirmed exoplanets out of the trillions and trillions of exoplanets. So yeah. So now let's talk about the methods that astronomers use to find those 4,000 planets and hopefully more and more of exoplanets in the future. Our method that I want to talk about is the simplest method. It's called the direct imaging, and this is very simple. تحطوا telescope, you point it to a star, لأنه بتعرفوا إنه around stars you have planets, and you take an image. If you are lucky enough, you would be able to see planet هون, and another planet right there. Star is right here, okay? Don't be confused. هون في a black disk. نحن مغطين الضوء اللي جاي from the star itself. So we do this on purpose to block the light coming from the star to be able to see the planets more. So this is called the direct imaging. You point your telescope, تحطوا كاميرا كتير منيحة, you take images, and you hope for good luck إنه تلاقوا شي planets orbiting around the star. Now, this method has been used to find exoplanets, but it's not very efficient because you know, the planets are so small compared to the size of their stars, and they are really far away. So taking an image, a photograph with the camera to find those exoplanets شي كتير صعب. كأنكم عم تاخدوا صورة لبناية which is really far away and you're trying to find a very small ant on the wall. يعني although you know that that ant is at one of the walls of that building, بس إنه تاخدوا صورة بكاميرا على هيدا البعد will not show you enough details for you to detect what you are looking for. But anyway, this is one of the methods that have been used. The direct imaging مثل ما اسمه بيقول. The second method is what we call the astrometric method. The astrometric method depends on the wobbling of stars. The wobbling of stars. If there is a planet orbiting around a star, مثل هون, if this planet is orbiting around that star, because the planet is orbiting around the star, this star will feel the motion of the planet and it will wobble. It will move in circles around the center of mass. This is what we call wobbling. So if I point my telescope to a star and I see it wobbling in circles, I can then tell that there is something close to that star which is causing it to wobble. And that thing will most probably be a planet. This is what we call the astrometric method, which looks for wobbling, movement of the stars around a center of mass. This is what we call the wobbling method. Now, لنحكي فيها أكتر, our sun is no exception. This is our sun. بس كمان our sun has planets orbiting around it, and because of that, look how the sun is wobbling. It is wobbling, it's doing a circle around this red circle. This is our sun wobbling due to planets orbiting around it. So أنا بس بدي أشوف planets around other stars, بنحط التلسكوب, we look for such motions. If I see such motions, I calculate some details at distances about the speed and so on to discover planets around it. You see هون الplanets بالsolar system عم يبرموا حوالين الsun, causing the wobbling of our sun. Cool. I think this is a cool method. Wobbling of stars. Yeah, so this is method number 2. This is another example. شو يعني wobbling. شوفوا as the planet orbits the sun or a star, شوفوا كيف بيعمل that wobble, that circle in the sky. So yeah, this is the wobbling. This is the astrometric method. The second method we use to find exoplanets. It's a good method. The third method, كمان it depends on wobbling, but we don't look at the wobbling directly. What we look at is radial velocities. أو to be more specific, we look for redshift and blue shifts. يعني as the planet, this is the same image. As the planet orbits around the star here, the star will wobble in a circle. طيب, if the star, I'm gonna move into this image here now. So yeah, if the planet is orbiting around the star is wobbling. If the star is wobbling towards me, يعني بهاد direction, and then away from me, someone with a telescope observing that star will see blue shift of light as the star moves towards my telescope, and then they will see a red shift of the light as the star goes away from me. So if I'm looking at a star and it's moving towards me and away from me, then I will see red shifts and blue shifts, then I will tell, okay, what causes the star to move towards and away from me is probably a planet that is orbiting it. This is what we call the radial velocity method. Let me show you more, Akid. One example, a planet orbiting around a star. Now, see, behind the part, the star is moving away from me, so look at the light redshifted. Now the star is moving towards me, look at the light being blue shifted. This is the spectra of light. This is how things happen. This is how we use the radial velocity. As the planet orbits around the star, يا بتجي لعندي I see a blue shift يا بتروح away from me I see a red shift. So looking at stars and looking at their blue and redshift lights will yield to let us know if there are planets orbiting around those stars or not. It's a cool method, it's a nice method, and it is an efficient method. لأن radial velocities يعني the redshifts and blue shifts they depend on spectra, and spectra is very efficient and very accurate. So yeah, هيدي the second radial velocity method. Okay. So حكينا نحن عن direct imaging, حكينا عن the wobbling of stars, what we call the astrometric method, حكينا عن the wobbling of stars كمان which causes the radial velocities, the redshift and blue shifts, حكينا عن هو 3 methods. بعد في عنا 2 methods. One of them is called the transit method, and I think this is a really cool method. And you know, the concept of it is really straightforward. تصوروا انه عم تطلعوا على هالنجمة on this star, and then look at this little planet. So this little planet is passing between my telescope and that star, and if this happens I will see a shadowed, a dark area, the dark side of that planet. So فإذا إذا في planet orbiting around that star, every now and then it's gonna pass between my telescope and that star. And if you guys are looking at something so bright like a star, وبيمرق شيء بينكم وبين star, what's gonna happen to the light coming from that star? I mean, logically it should be diminished. The light should be slightly diminished because some part of the light is being blocked. مثل هون. And this is what we call the transit method. I know it's not very clear yet, so let's look at this one here. For us to apply this method بنعمل شيء اسمه light curve. يعني نرسم هذا الشيء هون. I'll go back. So we draw time on the x-axis, brightness of the star on the y-axis. إذا ما في شيء بيني وبين الستار, I see a straight line. إنه the light coming from that star is constant, it's not changing. Now as the planet comes between me and that star, يعني من هون لهون, this is what happens. The light will be dropped and I will see a diminished light coming from the sun or from the star. بيبقى لوقت من الأوقات بيرجع بيطلع as the planet exits our path. بيرجع بيصير طبيعي. This is very similar to eclipses. Think of a solar eclipse. بس تطلعوا على الsun in a solar eclipse قبل ب 5 minutes عادي بيكون في sun. Constant light, constant brightness, nothing is changing. As the moon passes between me and the sun, the light from the sun will be diminished, والlight الbrightness تبعه بيقل. And this is exactly what we do with the transit method. We look at stars وبنشوف any diminishing of lights happening coming from those stars. هيدي a light curve, a planet passing between me and the star. You see the diminishing of the brightness of the stars. هرجع عيدها. light curve بلش يمرق بالبلانت, نزل الضوء, رجع طلع, and then it's constant again. And this will be periodic. نضلنا عم نراقبها ونشوفها many times. And this is what we call the transit method. I hope it's clear. Well, it's a very effective method. And before I go to the last method, I would just want to tell you, you can get properties for the planets from those light curves. يعني, look on. This is time on the x-axis. Is a time for the planet to orbit around that star was longer, أكبر من هيدا, يعني this gives me information about the distance between the planet and the star. ليش؟ لأنه if the planet is very close to the star, مثل Mercury around the sun, the planet will move really fast around the star, and thus the time of diminishing will be small. أما إذا the planet is very far away from the star, مثل Jupiter or Saturn, they will move really slowly around the star, and thus they will block the light from the star for a longer time. I hope you get what I mean. هاي واحدة. شغلة تانية, this light curves كمان gives me information about the size of the planet. If the planet was so large, then I will see more diminishing of the brightness of the light. صح؟ If the planet is so small, ما كتير حيصير في a decrease in the brightness of the star. This is very general way to explain this. Okay? يعني حكينا عن the direct imaging، ناخد صور عادي، the astrometric method, the radial velocity method, the transit method, and now we talk about microlensing. Okay? Now microlensing شوي هيك ثقيلة لأنه it has to do with Einstein and relativity and other complicated topics. Best, I'll explain it. Look, I'll give an example. Let me see. No. طيب. This is a planet and this is a star. Okay? If you are looking with the telescope, هاي star كتير بعيدة and this planet is close. If you are looking at this star, okay, forget about the example. I want to give another example. I think it will be better here. So this is a star. No, I don't want to give this example. So it's kind of hard to explain this هيك على الصورتين هول because in class I sketched something. So I'll just do it briefly and maybe you can do some reading about this. Okay? So هرجع لهذا الexample. This is star number 1. Let's call this not a planet, star number 2. Okay? And this is my telescope. And assume that star number 1 is really far away and star number 2 is kind of close to Earth. Okay? Just take this assumption. إذا عم بتطلع with a telescope on star number 2, I will not be able to see star number 1. ليه؟ لأنه star number 2 is blocking the light coming from star number 1. I mean, this is common sense. حاولوا تطلعوا انتوا على لمبة in your homes or something and try to block the light. حطوا ايدكم between your eyes and between that lamp and you will realize that of course your arm, your hand will block the light coming from the background lamp. أكيد. And so this is a similar example. Star number 1, star number 2, our telescope. If I look at star number 2, star number 1 should be blocked. ما لازم شوفها. بس تذكروا انه this is a star not a planet. شو بدكم بالرسمي. So what microlensing says is the following. بتقول انه if there is star number 1 and star number 2 and they are star number 1 and star number 2 and they are all aligned, if this is the case, people with a telescope or people on Earth can see the light coming from star number 1. لأنه as light travels from star number 1, it will feel the gravity of star number 2, and instead of it being blocked by star number 2, it will be lensed. حيطلع عنه الضوء حيطلع عنا لstar number 2 and it will pass through my telescope. So this is, again, I'm gonna explain this one more time. Sorry for the confusion. بس again صعب اشرحها هيدي. This is star number 1, star number 2, telescope بيجي الضوء من star number 1. The gravity of star number 2 will bend the light. هيك قالنا Einstein. It will bend the light to move around the star and then it will come to my telescope. This كمان هون from that side. The light coming from here will be bent because of gravity and it will pass through my telescope. يعني إذا بتحطوا إيدكم between you and a lamp to block the light coming from the light coming from the lamp will be able to bend around your hand and pass through your eyes if your hand has enough gravity. ليه ما بتزبط بالexample تاعول lamp and our hands؟ لأنه our hand doesn't have so much gravity. بس a star as big as this one مثلا will be able to bend the light around the star from the light coming from star number 1. Okay? Yeah, so this is the idea of microlensing. So إذا في planet هون exactly where I'm pointing the the button إذا في a planet هون orbiting this star, what's gonna happen is that the light from this side will be bent even more than it is now. إذا في planet هون, it will bend this light even more, يعني هيك شيء, and then it will pass through my telescope. So what astronomers look is for extra bending of light that is coming from background stars. I know it's a bit hard to imagine عن شو عم نحكي. هون في star number 1, star number 2. Star number 2 في حواليه planet. Star number 2 is gonna pass هيك between my telescope and star number 1. As it passes, I expect إنه this star will block the light coming from the source star. أما بس تشوفوا هون بتلاقوا إنه this star is bending the light around it that is coming from star number 1, and so on. وإذا في planet مثل هون بيصير في bend from this side more than from the other side. This is what we call the gravitational lensing. Please إذا مش مفهومي, you can ask me, you can email me, write me, or you can read a bit about this. I will just show you this آخر شيء. No, this is, well, it doesn't look like a galaxy, but it is. هذه galaxy قريبة, and this is also a galaxy كتير بعيدة. The light from this galaxy, or the existence of this galaxy, should block the light coming from that galaxy يلي وراها, يلي ما لازم نشوفها. بس the gravity of this galaxy is bending the light of the background galaxy, and it is showing it on my telescope. So this not only applies for stars, it also applies for galaxies, for black holes, and for everything with gravity. I think the last method is more complicated than other methods. بس إنه فهموها شوي. These are the 5 methods we use to find exoplanets in our universe. هذا chapter 8, not 7, sorry. Yeah, so these are the methods we use. أحسن methods هني the wobbling of stars, the astrometric method, the radial velocity method, and the transit method. هول أحسن methods. أسوأ methods so far هني the direct imaging and the gravitational lensing. I hope this gives you a good review on chapter number 8. Again, if you have questions أو أي شيء, feel free to ask me. And thank you so much for listening.